Here's a quick tool that I made called stamp projection, and that is to, in a very similar way to stamp points or shape scatter or scatter shapes or scatter curve. It's to stamp images onto a surface instead of a UV map. So the stamp projection is set up in a very similar way to the shape scatter and the curve scatter tool. And so let's see here, scatter shapes. And we'll look at that, the standard shape scatter here. And I'm just going to put some test numbers in here. I'll save this HDA for you. All this is just a bunch of numbers, and they're useful to test out anything that requires a sequence of images, such as stamps. So let's have a look at what this looks like on the surface. So we'll pipe this in here into our base color. And the first issue you're going to have is that because it's stamping into UV space, it's stamping across these. So this is what the texture looks like, stamped across this UV map. So obviously the numbers are going to cross the UV seams, and you're going to have this issue here. Now you could hire the UV seam underneath the chin like I've done in the past, or somewhere else. It's very clean, which is great. That's one advantage of stamping on the map. But you do get, with a UV map trying to hide the seam somewhere else, you start to get an issue where the pixel sizes vary across the surface because of stretching. So it's kind of a catch-22, which is UV mapping versus pixel to world space size. And so stamping has resolution issues, projection stamping, but it gets around the UV seam issue and the pixel size issue. So if I put my stamp projection in there, and actually let's just put it in by itself, you can see here that I don't get the UV seam issues. So let's just over that the original texture of the pig to make it clear. There we go. And we'll set this back to top. All right. So just like the shape scatter, you can bring in various maps to control it. Since this is a stamp projection, it's projecting in 3D space. What it's doing is that it's taking in the scatter points here, and just to make it clear, I'll just show the points. So here's a bunch of points that are scattered on the pig head, and the pig head itself has normals, and what this tool essentially does is shoot the image along the normal to those pixels. Now I don't want them to shoot all the way to the other side, so we need a map to control that, and distance to control that. So we take our position map here, and our position map is where all the pixels are in 3D space on our pig. So here it is, RGB equals XYZ, so you can see where each pixel is in world space by color. And the way that I'm setting that up is I made this little test pig HDA, and I'll make an auto HDA and a bunch of other ones, but you can play with this pig one. I'll keep updating it. And inside of this, you can do this with a wrangle, which is create a world map. And the reason why I'm doing it instead of using ORG-P, which you can do in your raster geometry, is that it doesn't go over the edges of the UV seams, and you need that. So this is an OCL version of that I made of last year of the wrangle, and I find it's a little faster. And what it's doing is it's using barycentric coordinates, which is where am I in a triangle, versus Cartesian space, which is the grid, which is where am I in a 3D grid. So you can use that as well. I'll update it, report any bugs if you find any. And so I don't know if I'll fix them, but I'll try. Anyway, so this gets the world position and N in barycentric space, and outputs that from our HDA here. And then also I put in here the usual, texture spec and all the other stuff that comes with the test pig. I just wrapped it up in COPS because it's easier instead of having to make one all the time. So our test pig outputs the position map, normal map, and I take this position map and I added some transformation to it here if you wanted to adjust it. So let's just put that down here. So you could transform this for some reason if you wanted to. That gives you some flexibility with where the tool is going to find pixels for each point. And then we also need for each of these points, we need point attributes because the tool will take point attributes. For instance, color here, you can bring in the point color and add that to the stamp. So in here I've added the up vector. So let me see here where we can add that. Let's see if we can show up. Yeah, let's just turn on up here. Up. There we go. So there's our up vector. And I've added a bunch of other versions of the up vector here. So that means that that's the direction that the stamp's up, the image that's being copied onto the surface will point. And so I've given a couple of examples in there of setting that up. You can add a bunch of other attributes in here. An important one is the UV attribute. So anyway, so we scatter points with those attributes onto the surface of the pig. And then that feeds into the tool. So for each one of these points, it's going to use the up to orient itself and the normal to shoot in that direction onto the surface of the pig. So some other maps you can use. Here I'm getting a ramp and I'm shooting it down the Z axis, so the XY plane. And so let's look at what that looks like on our pig here. So, and then I animated the ramp. I just rotated it with the frame count. So you can see here, there's the ramp. So I'm gonna cut off at the top here. Let's just transform that so I don't have that issue. There we go. And so now you can see here I have a ramp that we can use to drive some values with our stamp here. So where I happen to be taking this mono map here is putting that in scale. And then also I did the same thing with transform, extracting a UV map and rotating a UV map, which is, you know, ramp of red and green in X and Y directions. And then same thing, rotated that here. So I'm also using that for direction. So if we look at the result of that, we'll put that on our pig here. You can see that as I move in time here, the ramp is rotating for the UV and the mono, and so scale and direction are both being affected by those two maps. You can see on the pig here as I rotate that around. And then they've also added this new ray trace node in Houdini 21, which is great. They use it for baking, or real-time baking, or close to real-time baking here, which is kind of awesome. It outputs thickness. You could calculate thickness yourself and put that as a point attribute, but it's kind of convenient to have here. And the reason why I want thickness is that since I'm shooting these images across the surface, again, I don't want them to appear on the other side. So let's look at what this map looks like here. We'll put that in our base color. So there's our thickness map, and what this does is it says don't project. So the white makes it project farther and darker projects less in my tool. At the bottom here in scattering, I've added a fall off for how far we project our stamps. So I'll demo that here. Let's just put that in here. There we go. You can see that there's this 7 doesn't shoot all the way through the ear. And so I have a couple of different depth modes here. So this one, I think 0 does nothing. And then 1 is with a fall off. And then 2 is using a ramp here. So this is driven by both the thickness map, which is how far to shoot the ray the image along the normal direction of the surface using its points, scattered points through the surface here, and that can be controlled here with a ramp, and then also positive and negative on each side of the point in the normal direction will also control the depth. I think that kind of wraps it up. There's a lot more to the tool that I could show, but I think that's probably good enough for now. I'll save the HDA in here, embed them for the pig, the barycentric pos and end coordinates, and the test number HDA, and of course the stamp projection HDA will also be embedded in the HIP file.